Good afternoon. I've been asked to set the stage, kind of define the challenge that is before us with Repack. The FCC defined Repack in one of their early PNs, and it is basically a reorganization of the band to the remaining spectrum with all of the remaining stations. We did modeling for a presentation that was created for the NAB, but based on 100 simulations that the FCC ran 2 summers ago on 2 different clearing targets, one at 126 and the other at 84 megahertz. So the numbers you see before you show a range of stations that are likely to be repacked if the clearing target is 126, and also a range of the stations remaining on channel and the stations needed to clear the spectrum. Same thing for 84 megahertz, and you'll notice that the number of stations to repack at 84 actually goes up over what it was at 126. You've probably seen a higher number in the most recent PN that came out, but as I understand from the webinar, that includes the Canadian stations as well, and the numbers that are US only seem to agree with our higher end number that is shown in this particular report. So what happens in post-auction? Well, there's an optimization process, and this will occur looking at feasibility first of all, and then looking at how to keep stations that are on a channel that is not cleared on that remaining channel. Also, how to minimize at priority 2 the aggregate interference experienced by any station. Priority 3 is to avoid reassignment of stations with high relocation costs, and there are many of those, particularly in the larger markets. And number 4 is to prioritize assignments to channel 5 in low VHF and off of 14 where we have land mobile issues at the low side of channel 14 in UHF. Repack timeline really triggers once the final stage rule has been satisfied, and the next step for that is the FCC will issue a confidential letter to each station with their post-auction channel assignment so that they can begin planning before the official gun is fired, which will occur when the public notice is issued that lists all of the channel reassignments for all of the stations. The stations will have, as Bob Weller pointed out, 3 months to file their construction permit application after they've received the public notice. There will be a post-auction filing, series of post-auction filing windows for, first of all, stations that are unable to meet the technical parameters in the reassignment channel, and then the second will be for all other stations assigned to new channels wanting to amend the configuration. Construction deadline runs up to 39 months after the reassignment PN. So the reassignment PN issuance is really the starting timeline for the process. Let's take a look at what the impact is on a typical station's RF system. So here we see a typical DTV plant, the transmitter system beginning with the exciter through the power amplifier, followed by a low-pass filter, followed by a mask filter, which is a single channel device. If the station shares antennas and a common transmission line, there will be a combiner. This is not the case in most installations, but there are installations such as Empire State and others where combined antennas are used, and the combiner is a very selective, channel selective device, followed by transmission line and then antenna. So what's impacted by Repack? Well, transmitter very likely. The mask filter is very likely. The low pass filter is possible. Combiner is pretty much a 100% guaranteed replacement. Transmission line, which might at first seem to be an area that wouldn't be impacted. Definitely if it's a rigid line, will have certain channels that it will not operate or perform properly on. And antennas, again, very likely. I would point out that in the inventory of antennas that was done last summer, I believe was the timeline, I noticed there were many antennas that were reported to be broadband, and I believe what the station engineer did was look at the spec sheet on a single panel and not consider all of these panels formed together into an array. And when that happens, the antenna is no longer a broadband all-channel UHF antenna system. We found, I believe, well over 70 in the cleared spectrum when we took a look at the information and found that they were misreported. Transmitters are likely to be replaced. Keep in mind that many of the transmitters out there for DTV are between 10 and 20 years of age. Many of the original UHF transmitters are banded into channel segments, meaning that they might cover a few channels either way of their current operating parameters, but definitely not broadbanded. And that's largely because of the fact that there are a combination of PA modules, or what we call pallets, that make up a complete amplifier plug-in assembly. And then there are devices like circulators that are also banded, but different banding from the amplifier pallets. And when you combine all these components together into an amplifier module, you'll find that there are a number of segments across the UHF band. So it's very likely that you'll end up with a channel or a situation where the amplifier is not capable of being retuned to a new channel. There are other considerations, for example, how to stay on the air during the transition. The fact that newer transmitters have a much higher operating efficiency. Serviceability is a lot better on the newer products. Long-term support. Keep in mind that many of the early solid-state transmitters, the devices are no longer available, and the companies like Gates Air and the others that are out there only have enough spares of the solid-state devices to maintain repairs, as opposed to going in and building all new modules for the station to operate. If it's a tube-type transmitter, tube prices and availability of tubes, the manufacturers do no longer, for the most part, stock the IoT tubes, and there are also safety issues. And of course, broadcasters are also concerned about future-proofing with ATSC 3.0 right around the corner. The high-power RF systems are again channelized, and in many cases not tunable, or only tunable a couple of channels either way from their current operating parameters. Transmission line, as I pointed out, this is a chart that Dielectric put together on their sectional line, and there are 3 different line sections, line length sections that are used in the industry, and you can see the channels where there's likely high VSWR that would prohibit the use of the line if you move from one of the lighter blocks to one of the red blocks in terms of channel reassignment. So will stations not changing channel be impacted? And I think the answer to that is yes, if they share a tower, if they have stacked antennas. And I'm very familiar and work with a station where we have stacked antennas with one station that's on the top that's likely not to be repacked, yet the station below it on the tower is very likely to be repacked. If you're operating on a shared antenna and shared transmission line, in all of those cases, you're going to have an impact on the station. The other large impact will be on FM stations, particularly FM stations that share a tower. Gates Air did a study that looks like this. There are 2,368 FM stations and translators that share television towers. Over 1,300 of these are full power or high power FM stations, and these stations are scattered across 1,153 tower sites throughout the U.S. So it's very likely that FM stations will be impacted. We'll have to either reduce power, go off the air, or relocate to a temporary site during the construction on the main tower site. Let's look at some of the logistics involved. So we just had a PN that came out that proposes how the post-auction transition plan will work. It divides the stations into 10 different transition phases. There was a lot of work done to kind of balance the load across those phases so that one phase was not tremendously larger than the other. The phases are different lengths in terms of their duration, and that was done largely to break up the daisy chains that occur in the stations when they are reassigned to new channels. So there's a phase alignment tool that has been put out there. There are a lot of assumptions that have been based into the plan, and Sasha, I see, is smiling back there. He knows what the assumptions are. I've looked at it, having done 2 surveys or studies for the NAB, and I think that the things that are going to be issues will be zoning, permitting land use, which certainly you've accommodated a little bit of that at the front end, but we all know from history that places like Denver and San Francisco, there are horror stories about 2-year and 3-year windows to get the permission. We've got the Bureau of Land Management that controls a lot of the mountaintop transmitter sites, and you've got to get permission from the appropriate people to be able to even conduct any work on those sites. Weather factors, and again, I skimmed I wasn't able, Sasha, to be on the call on Monday, but skimmed it last night, and you talked about the fact that weather is really not baked into the situation. Well, I know that some people have said, yeah, we'll work in almost every kind of weather, including ice and snow. The reality is that that's not a safe situation. So weather factors, tower structural changes, and what about supplier delays? Not every supplier is going to be able to crank out your product at the time you need it. So I think there are a number of considerations that could impact the plan that's been put together. I certainly applaud the fact that it's phased and that we've tackled at least an approach on how to break the daisy chains. Here's a look at the 10 phases. I'd also note that while we have phases, all the phases start at the same time. So we're still going to have a resource contention issue at the beginning of the process. I'm glad to see that we've got a test period baked in there. For the most part, I think if we had staggered phases, meaning that the starting point was staggered, we would probably have a better approach. I'm still doubtful that the resources are sufficient to be able to do all this in 39 months. Here's a look at the phase size distribution. And the red bars, by the way, represent the Canadian stations that will have to be repacked in order to make the plan work. Some of the reimbursement logistics, there's a filing that goes with your construction permit application that creates the budget for your project, and it needs to be based on reality, not just picking a catalog price, but the catalog has just recently been updated. I've had some of my friends at Gates Air look at it, and others have looked at it, and again, I applaud you for doing a good job on the catalog. I think it's a great start. There are certain costs, however, I think that have been overlooked and are not reimbursable. So for example, if you have that FM station, you're a dual licensee, who's going to cover the cost of moving the FM station? If you're a tenant on a tower and you're an FM, who covers that, Peter? Those are all the gotchas that we seem to have in the plan. So the initial allocation is deposited into a treasury account that you can draw on. The commercial stations get up to 80% of the estimated cost. The non-coms up to 90% of the estimated cost. The FCC will require progress reports along the way to see how you're doing, what the progress is, and see where you are on spending. And the plan is within the 39-month window to have a true-up of the actual costs versus the projected costs. You might have to give some of those dollars back. You might have to get more dollars than what you originally were budgeted. That's all part of the true-up process. And again, I mentioned the catalog. The catalog was originally done by Widelity in 2013. Transmitter technology has advanced considerably since the 2013 time period, and cost increases on labor and services have gone up, and the commission, I think, has resolved that quite adequately with the latest catalog that has come out. There are some open issues yet for full power and Class A stations. Again, I think the biggest one of these is how are we going to do all this in 39 months? And whether or not the $1.75 billion reimbursement fund is going to cover it. I don't think anyone originally thought there would be as many stations that would be repacked as the modeling now shows, and it's very likely that the 1.75 will be woefully short. For particularly the western stations, how to account for loss of translators. For the LP TVs and TV translators, there will be a limited displacement window that will take place after the full power and Class A's have their applications submitted. The LPs and translators will be able to maintain operation until the wireless owners of the spectrum are actually going into service, and I believe it's a 120-day notice that has to be given before they are to turn off and turn the spectrum over. Okay. For the translator stations, how many vacant channels will be there? Will they be unavailable or available for displacement? How long will it take the wireless operators to commence operation? Is this a 3-year process? Is it a 6-year process? Are we sitting on spectrum for a lot longer? We don't know. And how much will the displacement cost, and who will pay? Certainly not in the reimbursement program. Again, a large impact on the broadcast industry technical resources, large demand for consulting engineers, for structural analysis, for transmission system installers, tower crews, both new towers and antenna installation and tower reinforcement. Broadcasters may have to look at alternative resources from who they're likely or would normally use for those services. And again, projects may be delayed by many factors that haven't been accounted for in the plan. And with that, let's turn the session over to John, and he'll moderate our panelists.